Good afternoon. So in the screen, I will be showing the PowerPoints. At the same time, Dr. Sunil R, my colleague, will be demonstrating the same on the machines which are put there. See, anesthesia workstation or anesthesia machine per se is a salient and indispensable component of the operating room. You cannot imagine an OT without an anesthesia workstation or machine. So this was a very old one. This is the original Boyle's machine. You can see it is a simple pneumatic anesthesia machine. What's the meaning of pneumatic? It means it is operated by air or gas under pressure, right? And now this is the most modern workstation, and you can compare both. So what's the difference between anesthesia machine and a workstation? The difference being the traditional pneumatic machine has evolved into a complex one. You can see on the right side, it's a very simple thing. On the left side, it is made more complex, having an electrical component, digital, mechanical, and also the pneumatic multi-component system. Or we can say that this workstation contains the original anesthesia machine, that is the pneumatic component, plus monitors, ventilators, vaporizers, breathing circuits, scavenging systems, drug delivery systems, suction equipment, data recording as well data transfer. What is the purpose of making a simple machine into a complex workstation? The answer is safety, patient safety. But remember, apparatus of reliable appearance gives you a strong feeling of security, which is often not supported by facts. So a critical attitude often prevents unpleasant surprises. So what's the take-home message? You may be using the most modern thing, but be vigilant. Okay, let us start with the components of pneumatic system, because this is the foundation on which the concept of workstation is built upon. So let us go back and learn what are the components of pneumatic system. All of you are aware that it has got a high pressure, intermediate pressure, and low pressure system. And high pressure starts from a point to second one, which I tell you later on. Intermediate pressure is having boundaries, and also the low pressure. Which are the boundaries? From cylinder to reducing valve or pressure regulator is the high pressure component. From the pressure regulating valve to the flow control valve, not the knob, is the intermediate pressure system. And downstream of flow control valve is the low pressure system up to the common gas outlet. So this picture tells you, can you see? From the cylinder to the pressure regulator, this is on the oxygen side, high pressure system. From the pressure regulator up to the flow control valve is intermediate pressure system. And then you can see from the flow control valve up to the common gas outlet is the low pressure system. I think Sunil will be showing it in the machine.
Good afternoon, everybody. We will first show the parts of the machine, the old anesthesia Boyle machine. Here we have, as you said, three system: high pressure system, intermediate pressure system, and low pressure system. So high pressure system, it includes the cylinder, the hanger yoke assembly, the pressure gauge, up to the pressure regulator. Can you all see this pressure regulator? Please show it. This is the pressure regulator or the pressure reducing valve. So this is the oxygen side, and here you have the nitrous oxide side. So we will be discussing a bit detail about it later. Okay. So now you coming to the intermediate pressure system. That includes the pipings connecting from the pressure regulators till it is extending to the, this is an oxygen failure alarm. It's an electrically operated oxygen failure alarm, and there is a pressure relief device for the intermediate pressure system, which can leak at times. Some of you may be seen that. And in the intermediate pressure system comes also this oxygen flush and the Schrader quick coupler connections for ventilator or jet ventilators. Can you see this downside? This all comes under the intermediate pressure system. And then it extends till the flow control valve. So from the pressure regulator up to the flow control valve is the intermediate pressure system. And you can see that there is a connection from the oxygen piping of the intermediate pressure system to the nitrous oxide pressure regulator. So this is the master and slave mechanism. When the oxygen pressure is down below 25-30 psi, the nitrous oxide pressure regulator will cut off and nitrous one comes into the machine. So it is also called hypoxic guard or master and slave system. Now coming to the low pressure system, that includes the flow control valve, torque tubes, and the back bar assembly, including the vaporizers. Here you can see a back pressure relief valve. Some machines you have a check valve so that the pressures are not reflected into the low pressure system, and it extends till the common gas outlet. That is a basic classification of a pneumatic system of an old machine. Okay.
Thank you. So let us learn what are the components of the high pressure system. Hanger yoke, he already mentioned that. Cylinder, pressure gauge, and pressure regulating valve. I just go through these components. What's the function of hanger yoke? It is just orient and support, because cylinder has to hang on to something. It should provide a gas tight seal so that the pressure from the cylinder is not escaping out. And you have to ensure that flow is unidirectional. It goes into the machine only. So this is a hanger yoke. This is the hanger yoke of the modern workstation. There's not much difference. So let us learn the parts of hanger yoke. What is this? This is the body of hanger yoke, right? Then this is the retaining screw, which actually fixes the cylinder to the hanger yoke. And then comes nipple, through which gas enters into this machine. And then comes a washer, which is called Bodox seal. And then comes two pins, you can see there. They are called the pin index system. And then there is an inside. When you move inside, there is a filter which actually prevents the dust going in. And there is a check valve assembly. It is the check valve assembly that makes sure that the gas is flowing only in one direction, so that no gas comes out of the machine into the cylinders. This is the retaining screw. You can see it clearly. Retaining screw. Swirl gate is just above that. So this is the structure of a check valve assembly. You can see that gas is flowing towards the machine only. It is a unidirectional flow. Only that this never happens. No flow backwards. Now what is the importance of Bodox seal? See, if the Bodox seal is broken, the machine, you cannot use the machine with a particular cylinder. So always keep spare of Bodox seal. And the function of Bodox seal is that it makes a nitrate seal between the cylinder and the cylindral valve and yoke. And it is a neoprene disc. What's the purpose of keeping the metal around it? If there is no metal, when the pressure increases, it will just break or burst. So the metal will prevent that. And always keep an extra washer for emergency. Never put two washers, because that is going to nullify the pinning system. And what is the function of this? Have you seen this? What's the name of this thing? This is called a yoke plug. And the function of yoke plug is you can close the inlet when there is no cylinder. I said about the unidirectional valve, but sometimes it may fail. So there is a chance that the gas can go back into the cylinder. If there is no cylinder, there is a chance of gas just escaping out. So to prevent that, you have to put a yoke plug. You can see a chain also. So these are the parts of hanger yoke. body, retaining screw, nipple, index pin, washer, filter, and check valve assembly. Over to Sunil.
So I think you can appreciate this hanger yoke assembly. I have removed the cylinder from one side. So you can see the swivel gate, the retaining screw, and you can see the nipple and the pin index system pins for the oxygen. And here inside, there is this is the board seal I have kept out so that you can see. So inside this hanger yoke assembly, there is a one-way check valve, because if you remove a cylinder or a yoke block from here, even if the other cylinder is open, it should not leak through this side, because but sometimes there may be some leaks, so that to prevent that you have to keep a yoke block. Okay, so coming to this pressure gauge, this is a Borden type pressure gauge, which you may be all familiar with. It has safety features, including from the front side it is made of thick glass, whereas the back side it is made of thin covering, plus there is a rupture disc here to prevent breakage of glass during high pressure. So here it is already ruptured. It is an old machine which is not of use. You can see that place where there is a rupture disc.
Now something about index pins. So the function of index pins is to prevent attachment of wrong cylinders to the yoke. So there are pins in the machine and holes in the cylinder. Only when these pins and holes come into alignment, you will be able to fix a particular cylinder to the particular yoke. Now what's the radius? Actually the holes and pins are arranged in the circumference of radius 9 by 16 inches. You have to note that. 9 by 16, and the pins are about 4.5 millimeter diameter and 6 millimeter long. You have to by heart it. And you can see they are arranged 0, 1, 1, 2, 3, no 0, sorry, 1, 2, 3, 4, 5, 6, and you can see the 7 in the middle. Now how to remember the pin index? Easy. Air, smallest word, 1, 5. Oxygen, a little longer, 2, 5. Nitrous oxide, longest, 3, 5. Okay? And carbon dioxide, 1626. Cyclopropane, you know the formula is C3H6. So its pin index is 36. Nandanox is having only a single pin index. Now, Sunil has already told you about the pressure gauges. Now, what about pressure gauges in a modern machine? The modern machine, usually pressure gauges are not on this side. It is in the front panel itself. You can see 2 rows of pressure gauges. The upper one, it is a pressure from the line, pipeline supply, and the lower one, it is from the cylinder. And it is name coded. You can see the names written. It is color coded. You can see the nitrous oxide is blue. And usually the measurements, the pressure is in kPa, kilopascals, as well in pound square inch. And as he said, it is a Borden type of pressure gauge. Whenever the pressure increases, the tube straightens and it is converted into a movement of the needle. And lowest pressure you can see always. Can you see the one? The 0 is between 6 o'clock and 9 o'clock. The earliest machine, it was in the 9 o'clock. So when you look at this thing, you may feel that there is some gas remaining. So the universal standard is this 0 should be between 6 o'clock and 9 o'clock. And always make sure, it is your duty to make sure that the gas pressure is in the green area. That is between about 2.5 to 5 or 6. If it is less than that, the working pressure is not adequate and your anesthesia workstation will not function. So make sure the line pressure is in that range. See, pressure regulator. I said from the cylinder up to pressure regulator is the high pressure system, right? What is the function of pressure regulator? It reduces high and variables. These adjectives are very important in a cylinder to a low and more constant of range of 40 to 48 psig. And physics, force is a pressure acting on an area. So a large pressure acting on a small area is balanced by a small pressure on a large area. Here, a large pressure acting on a small pressure. This is a very large pressure acting on a small area is compensated by the small pressure which is acting on a large area. This is the physics behind it. In the Viva, definitely somebody will be asking about that. Can anybody identify that this structure? This is important for you. Whenever the pressure exceeds a limit, this is actually a high pressure relief valve. High pressure relief valve. If due to some dust or something, if the pressure inside the regulator increases, this valve will burst off. So you cannot use it further. You need to replace that pressure relief valve. This is a pressure relief valve. Now, moving on to the components of intermediate pressure system. Already Sunil has said pipeline connections, pipeline pressure indicators, which I showed just now in the upper panel. Piping of the machine. Gas power outlets, you might have seen there are gas power outlets in the older machines, but in the workstation, these outlets are not there. Master switch, oxygen pressure failure devices, and oxygen flush. And flow control valves, that is flow control knobs and adjacent things. So this is an old one. What is being done? This is called a tug test. So whenever you use the Schrader system, you have to tug, you have to pull and see whether it is fitting or not. Sometimes what happens is somebody may fit into that hole, but it will not deliver any gas. When you open the machine, nothing will be coming out. So always do a tug test. And usually these are the modern terminal units. They are a little different. Usually there will be collar. I think Sunil will be showing that also. And when you trace the tube comes from that unit, that Schrader unit, reaches the machine, and there you can see it is the DIS, diameter index safety system. It is a non-interchangeable. You cannot just pull it out. It is a non-interchangeable. Difference is it is threaded also. The other one you can change. It is not threaded, but on the machine it is threaded as well as non-interchangeable. You can see this is a photo of a modern machine where you can see this clearly. Then master switch. Probably the first thing you do after entering the OT is switching on the master switch. It comes with the intermediate pressure system. You can see it. You can see the master switch. And this is the power failure indicator. Always look whether that is functioning or not. If it is not blinking, that means there is no AC coming to the machine. And you can see another LED also. What is that? It is a reserve power. That means your battery is okay. Suppose it is not functioning, you have to assume that battery has failed. So always look for these two indicators. You can clearly see that. And of course, once you switch on, the system check will start. Okay, I will stop there. Over to Sunil.
Now I think I will show these parts in the workstation. Here workstation, you can see that these cylinders are placed in the back side, and the pressure reducing valve, can you appreciate it? It is much smaller and different and sophisticated. And all these connections, they are mainly flexible tubings and transparent tubings are used. So apart from the old machine, there are too much tubings, and here we have another second stage pressure reducer also. So I will come to that later. Then first we will just show the front part also. So can you appreciate the pressure gauges, the green part where the normal working pressure should be here, where this and the master switch is here. And I have just removed this low pressure air flow meter assembly so that you can appreciate it later. So when we come to that, I will showing you, discussing it in detail in later. Okay.
So components of the low pressure system, it starts from the flow control valve to the common gas outlet. There are many components there in the low pressure system. The flow indicators, that means your bobbin, the vaporizer valves, back pressure safety device which is there in the older machine, pipings, and finally the common gas outlet. So this is a flow indicator. You can see it is also known as flow meter assembly. There is a tube, there is a float, there are stops, there is a scale, there is light also. Because if you are using in a dark room anesthesia, you need to switch on the light. And you know, tube is top tube. It is not a cylindrical one, it's a conical one. And there are two types of top tubes. The first you can see a constant taper. The second one is a variable taper. See, in the most modern machines, when a gas has two tubes, they are constant tapers. But in the older machine, usually it will be variable taper. That means with a constant taper, flow is slow, up to 1 liter, 100, 200, 300. With this variable taper, the whole 15 or 13 or 12 liter will be in the single tube. You can see this stop down. Can you see a stop? There is another stop up also, which prevent the sticking of the bobbin. And this is how the double tubes are placed. Can you see? Where do you use the double tubes? What is the indication for double tube? What is the indication for low flow? This is for low flow anesthesia. So you can see first tube is having 1 liter, and second up to 10 or 15. They are in series, not parallel. And there are safety measures in the knobs also, which I think Sunil will be elaborating. And regarding position of oxygen, you have to by heart that it should be always downstream. Okay. You can see here oxygen is upstream. So suppose there is a break, what will happen? The patient is getting nitrous oxide. Suppose the oxygen is downstream, what happens is, even if there is a breakage, patient may be getting oxygen rather than nitrous oxide. Can prevent hypoxia. And there are two laws, Poiseuille's and Graham's. Viva, they will be asking. Low flow, it is Poiseuille. High flow, it is Graham's. And light. Where is the switch of this light? It is somewhere there. You can see above that vaporizer, sevofluorine vaporizer, you can see a light. What's the difference of this particular flow meter from the other one I showed? This is called a virtual flow meter. Virtual flow meter. You don't see any bobbin. Here, you actually select the total flow and then percentage of oxygen rather than selecting different flows. Okay? And the most modern machines are having this virtual flow. And above that, you can see another panel. What is the importance of that panel? It tells you the inspired oxygen, nitrous oxide, and anesthesia gases also.
Okay, due to the lack of time, I will rush through. We have already shown you where the second stage pressure reducer is. This is a big difference from the old machine because there is only one pressure regulator, and the intermediate pressure system, it goes directly into the flow meter. Here we have a second stage pressure reducer with pressure for nitrous oxide around 26 psi and oxygen around 14 psi. So from there it goes into the proportioning system or hypoxic guard devices. Here we have the hypoxic device in the low flow system is. Can you see there is a mechanical linkage between the oxygen and nitrous oxide. I will remove this. Can you show this? There are sprockets with a different number of grooves so that when the oxygen is turned, nitrous oxide is turned on, try to open it alone, the oxygen also became 4. So this maintains a minimum concentration of 25% of oxygen, and this is the system used in this machine. And some of the machine they have a pneumatic system, but here this workstation we are using this mechanical anti-hypoxic device. So this is possible by reducing this pressure with a second stage pressure reducer. And there are so many other components, and the controls are electrically and servo driven, and I am not going to detail also of that.
This is a serious thing, right? Depletion of oxygen is depleted. User is not aware. What can happen? Hypoxia, cardiac arrest, finally brain damage, and lot of litigations. So you need to prevent it. With older machine, it was not possible. You could give nitrous oxide 100%. So hypoxic guard has been introduced, and Sunil already said There are two types of hypoxic guard. One is the mechanical, and Link 25 you might have heard about, and second is pneumatic. So this picture tells you about the mechanical linkage. The number of sprocket is 14 for nitrous oxide and 28 for oxygen. So when you activate nitrous oxide, oxygen is also activated. That is how you find out whether it is a mechanical one or pneumatic one. I will show you. So this is the pneumatic one. You can see there is some pressure on the oxygen side. It is actually pushing this piston. And when the piston is pushed, the nitrous oxide is able to move up. If there is no oxygen pressure, nitrous oxide cannot enter the flow meter. So this is the difference. How to detect? See here, there is a machine. I am trying to activate nitrous oxide. What happens? What did you notice? I try to activate nitrous oxide. Nitrous oxide bobbin has come up. Along with oxygen bobbin has also moved up. If it is an ORMC, pneumatic, I may go on turning, but nothing will happen. This is how you differentiate. But in this particular machine, instead of chain, it is a different one. Second stage, he has already said. And common gas outlet. There is something called circuit selector. Usually accidents happen. Always make sure that circuit selector is in the proper position. See, if you are selecting the closed circuit, it should be directed like this. And if you are selecting the other one, so when you select this closed circuit, in this panel, this will come either manual or VCV, if you have started ventilation. But when you turn the knob to the open circuit, you can see what will be in the screen? It is ACGO. So whenever you are doing pre-oxygenation, make sure that your patient is getting oxygen. Just look at the circuit selector and see whether it is in the right position or not. Now this is a circle system. I think I will skip this. Oxygen flush, 30 to 70 liter of oxygen can be given. It is used in an emergency. And problems, barotrauma, awareness because of dilution. And regarding vaporizer, I think Dr. Prasida has already told you, make sure that the knob is in the lock position. Otherwise, there will be leakage through that port. Now, this is the accessory oxygen supply. Most of the modern machines are having accessory oxygen supply, and also there is an anesthesia gas module. Can you identify this one? What is this? This is not an accessory oxygen supply. This is the backup oxygen pressure. If suppose your anesthesia machine breaks down, the accessories also will stop, but you will get oxygen from this breakdown flow. So you can continue oxygenating the patient. And these are the power outlets. See, the power outlets are meant for attaching your monitors and accessories to the workstation. Never attach a surgeon's cautery or something else, suction apparatus. No, you don't do that. Because these circuit breakers will switch off it. And there will be data communication ports also. And scavenging system you have seen on the poster side, just to scavenge the gases. And finally wheels, make sure it is clean. Make sure the brake is applied.
Finally, we will say a few words about the checking of the machine from the anesthesia technician's part. So, Ms. Mubina, our technician from Calicut Medical College, will be joining us. Okay.
Good evening, all. I'm Mubina from Government Medical College, Calicut. As an anesthesia technician, I would like to share some checking systems whenever we enter into our OT. Actually, anesthesia workstation is our masterpiece when we are working in the field of anesthesia. Once I enter into the OT, I will check whether the machines are moving or what, where the anti-static rubber tires should be working. It is a safety measure for an anesthesia machine. And I would like to tell you one thing. This is not the anesthesia machine. This is the workstation, which includes ventilator, vaporizers, flow meter, pressure, gas outlet, everything. Once if we enter to the OT, we should check whether the power switch, which comes under the electrical component of workstation, it should be on or off. And the power light indicates whether the power is supplying to the machine. And the other thing is that whether here it indicates the machine is connected to the power or have the battery reserve. Okay. And the battery reserve is very important because in between, if there is any power failure, the machine should not shut off. And the other thing comes whether the ventilator is working or not, and also the manual breathing circuit should be working. We will check through the breathing circuits, and all the newer machines having automatic checklets. When we all on the machine itself, it will be showing some cautions or something, some clues to check the machine, how to check, how to put in the bellows or to the bag. Then according to that, we can check the machines. Then the next comes vaporizers. Here it indicates whether the gas is liquid is there in vaporizers or what. At a time, we can connect two vaporizers in a machine, either, and here it is one locking system. Both the vaporizers, if two vaporizers you are attaching, means both the vaporizers should be locked. And also the one important thing, if you are going to remove one vaporizer, that vaporizer should be closed, unlocked, and should be removed. And also inserting. If the one vaporizer is at the working condition, you are not able to remove the other vaporizer. You should close it, and here one seal will come off. When it is open, the seal will be coming outside, and which will ensure the other vaporizer we cannot take. If we close the vaporizer, it will go inside, and it will be allow us to the safe taking of the other vaporizer. Next it comes, this is the primary thing where two or three cylinders will be attached to the workstation. And first of all, if we should check the cylinder, and we should ensure pressure gauges shows the capacity of the cylinders. Then next it comes, when we connect the gas outlets, gas pipelines to the central supply, it should display in this here pressure gauges. Oxygen, we have oxygen pressure gauge, nitrous oxide, and both air also. So if we connect it to the central supply, it will display. The gauges will be moving, and it shows whether the gas is coming to the machine or what. Next it comes bellows. Here also one pressure gauge is there, which will be displays the pressure inside the circuit. Through the APL valve also we can adjust the things. Then the next it comes the flush, which sir told, like whenever in emergency situations we uses flush. And here this also you should be check primary whether it is going to the ACGO or to the breathing circuit. Okay. And also here flow meters. In flow meters many safety features are there. Like first one is color coded for oxygen, white, blue, these all you can see. And also the touch coders. Whenever if you are turning to this side, and you can recognize which is the oxygen. Oxygen is the primary gas for us. And also the arrangement of the gases. Oxygen should be the downstream to the bar, because it ensures oxygen should be the first gas enters to the patient in order to prevent hypoxia in the patients. Okay, thank you.
I would like to tell you about one, there are so many tests, I will just mention one test, because you see the difference between the older and new machines. Then the new machines have flexible tubings. There is a possibility after service that the technician may have connected the nitrous and oxygen differently. So only by doing this single hose test, you can eliminate that. That by connecting the oxygen pipeline, you close every other, disconnect the nitrous pipeline, and just see if the oxygen is flowing up. So that only ensures, that single hose test only ensures that the inside connections are correct. So this should be done after service of the machine or starting of every week. So due to lack of time, we are closing up.
Every anesthesia workstation should have these two components. It is mandatory, there is no excuse. There should be a central bag, and there is a source of oxygen. Suppose your machine fails, you need to sustain the life of your patient. You can attach the bag and continue ventilation and troubleshoot. Thank you.